So in here, we don't, in this analysis, we don't see any time at all, So in reality, how this time introduced, we use sorry, yeah, time diagram. That's the time diagram. Now in this diagram, we are going to see all the variables, how they change with respect to time. So the top independent variable is time. So how I'm going to do it? So I'm going to draw the x first. Okay. That is x input. That's time axis. So in this one it was 0. In the previous one it was 0, 1, 0, 1 again. Now this x is time. So that's t, that's xt. Okay. Now the next thing that I'm going to draw with respect to time is going to be pulses, clock pulses. Clock. So let me write clock. So for each input, I must have a clock pulse. Why I need that? Because otherwise, if there is no clock for each input, that means that if there is no pulse, that means this input is not accepted by the circuit. As you know, the clock pulse means my memory elements works. If the clock pulse is 0, there is no clock pulse at all. That means this input is not accepted by the circuit. So therefore, I have got to put a clock pulse for each input. So let me write these inputs 0, 1, 0, 1. So I'm going to put here, this clock pulse here. Another clock pulse for input 1, another clock pulse for input 0, and another clock pulse for input 1. Okay, so if you look at our circuit, so there is a small circle here. That means negative edge sensitive, isn't it? So that means my sequential circuit will work on this edge because of that circle that I showed you already. So it says our present state is 1, 1, which is this one. So I'm going to put y1 and y2 here. And z. So what I am saying is this now. Up to now, these are external input and clock. These are inputs. And these are going to be capital Y1, capital Y2, and Z functions. So this is the mathematical model related graphs. So the first one, second one, third one, and that is small y1, capital Y1. As you know, small y1 and capital Y1 is going to be observed on the same wire. So what is the difference? Y1 is going to be observed first, and then capital Y1 is going to be examined next. So this is Y2, capital Y2, and that is Z. So from that, what it says, our present state is 1, 1 before the first clock pulse comes. So let me make it this. So my circuit, sequential circuit, is going to work on this edge. Maybe throw this down. Maybe on this edge. This is not straight line. I made a mistake, but I can correct it now. Let me correct it now. Okay. Now, before the first clock pulse, my initial state I am going to observe. My initial state is 1, 1. So small y is 1, small y is 1, 1, 1. Now I can, afterwards I will be using this state. Now I am in here. I haven't applied any clock pulse at all. I'm going to observe that 0 here, which is make it a different color. So 0 here. So I can draw the other z values because z is equal to y1 and y2. So once I found this, multiplications I am going to write here for this 1, 0. So the next state, 1, 1, if you apply 0, my next state is the same, isn't it? When you present state 1, 1, you apply 0, you come back to that. So my next state is 1, 1 again. So this is going to be continue until the next clock pulse negative edge comes. So that's 1, 1. So I am in this state now, and I'm going to apply 1. So you see here on that edge, this is where you accept the input. So for this edge, you accept this input 1. So present state is 1, 1. Your input is 1. Your next state is 0, 0. So my next state is going to be 0, 0. So my present state now is 0, 0 for this pulse. For this pulse, it is. For this pulse, this is the next state. For this pulse, this is the present state. Now 0, 0 state, and you are applying 0. And it says here no change. Because if your present state is 0, if you apply 0, you come back to 0. So your next state is 0. 0, 0. So your present state is 0 now. You're going to apply 1. So that's that one. So that means negative edge, you accept this 1. So your next state is 0, 1. So that's going to be 0, and that's going to be 1. So this is how the state variables are changing here, and multiplication of these variables is going to give me why I put 0 here. I shouldn't have done this. I made a mistake. I will correct my mistake. You see z function is y1 times y2. So 1, 1, 1 is going to be 1. And this multiplication 1, 1, 1, multiplication 1, 1, 1, multiplication 0, 0, 0, multiplication 0, 0, 0, and multiplication 0, 1, 0. So that's the output. Now this diagram is very important. Why is that? As you see, the time is included here. So this is xt changing with time. That's clock is changing with time. And this is y1 and y2 values changing with time, y1 and y2. Oh, sorry, it should have been time t. These are all independent variable, top independent variable, let's say t, t, and t. How that output function is changing in terms of time, how y1, y2 changing in terms of time. Okay, so the result that we have seen here is the same as we have found here, isn't it? So this one is the state diagram, includes time in it. This one is the output bit stream. There's no time included here. So that has got more information because it shows you which time what change is going to happen. So that's the end of this video then.